All right, so this is circles, angles, arcs, number 1. Circles, angles, arcs, number 1. And what's it say? This one is arcs by radius. A-R-C-S, by radius. All right, I was doing this with my other class. I think the only thing new here is arcs. Everybody say arcs.
Arcs.
And then in my other class, I said, do you know what an arc is? And they said, yeah, that's what Noah went on in the flood. Were you thinking that too?
Yeah.
Strangely enough, I've been doing this job a long time, and I don't know if that ever came into my mind. Okay, so in the Bible, the story goes Noah built an
Arc.
This is spelled A-R-C-S, arc, okay? In the Bible, it's spelled A-R-K, and it was this giant thing that looked something like this, according to historians. It was a giant boat, right? They loaded all the pairs of animals into the ark. 2 by 2 is the story that goes, and then they survived the flood, and etc. Anyway, it's the same sounding, ark and ark, but this one's spelled different, completely different. To my knowledge, there's no relationship between these two words, all right, other than they sound exactly alike. Okay, so, but fair enough to just get that out there, the ark, all right? And, and that reminds me of, that's interesting. I think an ark means vessel, now that I think about this, because you know what else is in the Bible? Did you see Indiana Jones? Yeah. What did he go find? This one's kind of old. Wow, maybe even before your time. Anyway, he went and found the ark. That was called the Ark of the Covenant. Now that I think about it, I think it's the same ark. I think it means vessel, because that was an ark where they kept the original 10 Commandments in the movie. It was this thing with wings on it, and it describes it in one of the books of the Bible. I forget. Anyway, off topic, but ark, and ark. Okay, everybody got the word ark? Let's do some review. Circle. Draw a circle in the air with your finger. Perfect. Who knows the actual definition of a circle?
Is it the set of points equal distance from the center or something like that?
Not bad. Very good, actually. Yeah, and that's the illustration that I love to do because it's really fun for me because I think of the old printers, those dot matrix. Here's the center, right? And then I go like this. Are you watching? If I did enough of them, and the dots got close enough together, they would change from dots into what?
A line.
Yeah, a continuous drawing surface, right? Technically, a line is a different thing, but yes, in our colloquial speaking, it turns into a single surface, right? So exactly what you described, the set of points and equal distance from the point called the center. I mean, that's the technical definition of the circle. So, is my finger on the circle right now? Is my finger on the circle?
Wait. Yeah.
Shake your head yes if it's yes and no if it's no. I got both. This is awesome. This is just like our non-math controversies, right? So, I mean, let's break the controversy. The technical definition says the set of points equal distance from the center. So my finger would have to be right here on the set of points, or some group of the set of points, right? That's actually the circle now in high school. But I know what you're saying, because back in elementary school, we said, here's a circle, and this is it. And you're like, there's a circle. You with me? So that's why your brain's thinking that, right? But now you advance into the more sophisticated understanding of what a circle is. That's the way we treat knowledge. We learn general, then we get more specific, and then we really go into the nuances, right, of what's happening. Okay, so fair enough, and thank you for remembering that. That's awesome. All right, so that's a circle. Let's talk about angles. Here's an angle right here. All right, technically speaking, 2 lines, or maybe rays in this case, rays being because they go up in that direction forever, coming together at a point called the vertex. But the actual angle we're looking for is this measurement in here. The measurement in degrees is our unit of measure, is a measure of what? What word do I want to use when I'm talking about an angle? Okay, and I'll give you a hint. Here's the old hint. Okay, I'm looking this way, right?
Degree.
Say it again.
Degree.
Degree is the unit of measure. What does it stand for, though? And here's I'll warm you up. I'll warm your brain up, okay? If I'm standing here and I rotate to here, how many degrees?
180.
180. And what did I do? What did I do? What's my physical action from here to here?
You turned.
Turn. Rotate. Everybody go like this. That's an angle. The turn or the rotate is the angle. Do you need me right now?
Yeah.
You do? Okay, hang on. Let me finish. Okay. So that's it. I mean, there's angle. That's your best understanding of that, is a rotation, right? How far, we start here and we rotate to there. How many degrees was that? If you say this is 30 degrees, all right. So now let's go to arcs. So let's take our circle that you know the technical definition of. Let's put a center in, and let's do an angle inside the circle. So here's an angle here, like that. What are these right here? What's this distance here called?
Radius.
Radius.
Yeah. I have no idea.
Emily, I'm recording right here, so. Okay, radius. So let's say this is 30 degrees. And this is, by the way, is called, in our notes, if you're taking today's notes, central angle. The central angle is 30 degrees. The central angle is 30 degrees. This part out here along the circle, this is the arc. All right? And so they'll say arc angle. What is the arc angle? All right, are you looking at the scenario? Circle, central angle, 30 degrees. That means when it moves from here to here, it's rotating 30 degrees. Fair enough? What's the measure of the arc angle? Take your time and trust yourself. What's the measure of the arc angle? If it's 30 degrees at the central angle, 30 degrees. Repeat after me. You guys are awesome. Okay, thank you. Okay, so 30 degrees. This just makes sense. There's a central angle and arc angle. Now, just to preview the next lesson, it's going to get more complicated. Let's say we've got chords here, and the chords don't go through the center, and this is 30 degrees here, this is 40 degrees here. If they say, how much is this angle, right? Now, this gets more complicated. It's actually an average of the two angles. 30 and 40 is 70 divided by 2. This one's going to be 35 degrees in here. So it gets a little bit more complicated, but for now, the central angle is the same as the arc angle. And what else are they talking to us about? So just some different examples of central angles and arc angles. So let's say we start, let's do another circle, something medium size. Let's say we start up here and the arc angle goes to here. How many degrees? How many degrees is the arc angle? Out here, this part. If I start here and I go this far,
90.
right? And what would the central angle be in here?
90.
Right? And then let's say we did it again and we kept going. So we started here, we went all the way around to here, right? What's the central angle?
180.
180. And what's the arc angle measure?
180.
180. Right? And so on and so forth. Let me make my circle smaller. Now say, okay, I'm sorry, I can't see. Go all the way around to here.
270.
Central angle. 270. And arc measure.
270.
Now, interestingly enough, at some point as you get around the circle, you start to look at this one in here. So they start to define the arc angle and I believe the central angle, and somehow my brain is forgetting because it's been a year since I've done this, they're going to call one a major and one a minor. So since this is the larger side, this is going to be the major arc angle, and the major, I believe it's called the central angle too, is you use the major and minor. Major just describing that you're talking about the 270 rather than the minor being that all of a sudden you could start talking about the 90 over here, right? You can talk about, there's always an opposite, just subtract it from opposite. There's always a subtract it from 360 and get the remaining for the central angle and the arc angle. And so one can be called major if it's larger, one can be called minor if it's smaller. What's the hint to remember this is the radius? Rat. What's the larger measure from side to side through the center?
Diameter.
Yeah. Diameter and dinosaur. Dinosaur. Sorry for the squeaks. Okay, that's it for now.